Hello and welcome. I'm going to introduce you to Planton Cloud. Here we are looking at an illustration that shows how companies operate today. Companies trying to build digital products and services, they hire a dev team and a DevOps team. They also create accounts on one of the three cloud providers, and the DevOps team will operate those cloud accounts. Company will also subscribe to a lot of developer tools like GitLab, GitHub, or JFrog Artifactory in order to help them ship software. So while development team is trying to build the product, the DevOps teams help the dev team to move fast. And eventually customers use the products and helps the company make money. Now, with Planton Cloud, this is how things could change. So company will still do almost everything else same, except that companies will start using Planton Cloud and they will have a smaller but stronger DevOps team. With the help of Planton Cloud, the stronger DevOps team will help the dev team to move much faster, and the dev team will also have a lot of features on Planton Cloud to further help with their development velocity. Bigger companies will prefer to create their own accounts on cloud providers and have the DevOps team create and operate the infrastructure on those cloud accounts, which gives them much more control over the infrastructure. On the other hand, there is startups or smaller companies who don't really care about the control that they get by creating their own cloud accounts. So in those scenarios, companies will hire dev team, will use Planton Cloud. Planton Cloud will provide the cloud accounts to host those products that their dev team is going to build. And Planton Cloud will fully take the ownership of managing the CI/CD tools, which will help the dev team move with highest velocity possible. Right now, we are looking at a common engagement between dev team and a DevOps team. So dev team will write the code and push the code to GitHub or GitLab. GitLab then builds and deploys the code written by developers into dev environment. And this dev environment is purely used for development team to test their changes and iterate before releasing the product to end customers. So a product typically has a website, a web app that has a lot of functionality for end users to use. And the web apps will be integrated with backend APIs, which can be written in Java, Golang, or other languages. And those APIs are connected to databases to store some data. Now, once the development is complete, applications will be promoted to production environment and customers will interact with the applications deployed to production environment. Dev teams will also have additional requirements from DevOps teams like good CI/CD automation, ability to create more environments, developer portal for ownership and managing microservices and databases, access management to control which team has access to what resources, dynamic DNS, SSL and other routing support, runtime configuration management for environments like environment variables, secrets, etc. and ability to stream logs and get more insight into the workloads running in the environments. Transparency into changes made to the infrastructure. Now, let's see how Planton Cloud can help dev team with these requirements get off the ground with a few lines of code in less than 20 minutes. Now, I'm going to create a company and I'll call it Life Apps. I'm going to give it an ID called Life Apps and click create. Now we have a new company on Planton Cloud called Life Apps LLC. I'm going to create a new product for this company and I'm going to call it as To-Do app. Give it a key called To Do and click create. Now that we have a company and a product, we are going to add a DNS domain that I have purchased earlier for this demonstration, and the DNS domain is pclifetodo.com. I'm going to choose Planton provided GCP cloud account to create the DNS server. Once the DNS name is added to Planton Cloud will create the name servers that we need to populate on GoDaddy.com in order to delegate the DNS. Once the name servers are added, we can come back a few minutes later to check the DNS, check if the delegation is successful on the internet. Let's proceed and start creating the resources for developers to start writing the code. The first step is we are going to connect GitHub organization for source code management. PC Life To Do organization, I'm going to give it the permissions. And once the code server is connected, all of the existing code projects that are on the GitHub will be imported in here. So we can visit the imported projects by clicking on Git repository. So this organization has multiple repositories and all of those have been imported. Now the next step in the process for us is to create what is called an artifact store. And the purpose of artifact store is to store the artifacts produced after build stage, like Docker images or jar files, etc. So we are going to create an artifact store. We are going to call it as main artifact store. We are going to choose Planton provided GCP cloud account, or it is also possible for you to connect to your own Google Cloud account and choose that cloud account to create this artifact store. Now that the artifact store is created, we also want to create what is called a machine account. And the purpose of this machine account is to allow your CI/CD system, in our case GitHub, publish artifacts into artifact registry. We are going to create that machine account and we will call it as CI/CD. We are also going to grant this machine account permissions to access the resources associated with this particular product on Planton Cloud. And we are going to grant it product administrator privileges, which includes all the permissions required to publish artifacts to artifact store and also deploy microservices. Next step for us is to create the dev environment. We are going to essentially create a logical boundary for all of the microservices and Postgres database. Click create, give it a name, choose Planton provided hosting environment, or else you can create your own hosting environments in your own Google Cloud accounts and choose those hosting environments and click create. Once the dev environment is created, we now want to create what is called a standard endpoint. And the purpose of standard endpoint is to create the DNS entries for the microservices for dev environment. So let's go back to the console and create a new, choose the environment, create pc-life-todo.com. And we also want to enable SSL and create. All right, now we have created the standard endpoint. We then want to create database. So go to Postgres clusters and create your Postgres cluster. Choose the environment, leave the name as main, and choose the endpoint and click create. All right, so we're going to go create a product secret to store the database password. Once the Postgres cluster is ready, copy the password and update the secret value. Now that the database in dev environment is up and running, we now want to move on to creating microservices. First, we'll work on deploying the website. So for that, we are going to go to code projects and first create a new code project. We are going to create it on GitHub. Project name is website, and we want to create a simple HTML CSS website, and we want to call this Life To Do app. Click create. A new code project has been created on GitHub, and we can visit that Git repository, and this repository contains the basic HTML and CSS code that is required to a website. Now let's move on to creating our REST API server, and for that we need the host name of the Postgres cluster, and we are going to use kubedns instead of a standard external DNS, and we are going to copy that. We would also need the ID of the secret in order to create the API code project, so copy that. Now create a code project for our API microservice. We are going to use Java Postgres template, provide the host name of the database and also the ID of the secret that we have created to store the DB password. We are going to create our third code project. Name of the code project is web app, and we use Next.js REST API code template. Name it Life To Do app, and the endpoint to access the API is going to be API main.dev.pc-life-todo.com. We have to attach machine account to each of these code projects to authenticate them to communicate with Planton Cloud. Each of the code projects running the pipeline communicate with Planton Cloud to grab some information and be able to authenticate to publish artifacts to artifact registry. In order to accomplish that, we are going to attach machine accounts to each of these code projects. So we select the machine account that has required permissions and click on create. When a machine account on Planton Cloud is attached to these code projects, the actions variables are automatically configured by Planton Cloud. Now that we have created all three code projects, we are going to create new microservices to link the code projects to target environments. First, we'll create a microservice for website, and the code project is going to be the website, and we want to deploy it to dev environment and leave the remaining as is. Now we have to create 2 more microservices, and we can leverage the clone feature on Planton Cloud. So we are going to call this API, and the code project is going to be API, and remaining should be similar to the website. And we want to create another one, so click clone again, and we are going to call this as web app, and remaining should be similar to the cloning project. Now that the 3 microservices have been created, we want to add CI/CD pipelines. Right now, the code projects don't have CI/CD pipelines, so they cannot be automatically deployed to the environments. So we are going to add CI/CD pipelines by clicking on what is called adding magic pipeline. And as soon as the operation is complete, you can refresh the page on GitHub to see that the code pipeline has been added by Planton Cloud. And this contains all the files required to build and deploy the project to the environment that we have created on Planton Cloud. We are going to repeat this for the other 2 microservices. Now that Magic Pipeline has been added to the other 2 microservices, we'll go and wait until GitHub successfully executes the build and deployment steps for all 3 code projects. Now that we have created all the resources required for the dev environment, including 3 microservices, on which pipelines to deploy the microservices to this environment are currently in progress. So in the meantime, we can proceed and create a similar replica of this dev environment to deploy our production environment. To do that, we can leverage the clone feature on Planton Cloud. Now let's go back to the console, go to product environments, and click on creating clone. So we want to call this as production, and this is a production environment, and we are going to leave the remaining as is and click create. Alright, now we see that a new environment has been created. So the clone operation will ensure that all the resources that exist for dev environment are also created for the production environment. So we see that a new Postgres cluster has been created, and along with it, a database password secret has been created. An endpoint for production has been created. And finally, we can see that the target deployment environments for the microservices have automatically been updated. So we essentially have everything that is needed for the microservices to be deployed. We want to make sure that the database password for the production database is updated in the secret value. So we're going to go grab the value and go back to the product secrets and update the value of the production database to the new value and click update. Next thing that we have to do is we have to update the code projects to separate out the configuration for dev and prod. I am on my terminal and I logged in using my Planton Cloud credentials on Planton CLI. It is possible to clone all code projects associated with this product using this one command, but remember to configure SSH to be able to clone these projects. Planton CLI will query the backend and list out the repositories and clone them to your MacBook. Now we want to update the deployment configuration for the API and web app so that when they are deployed to different environments, they use the right configuration. First, let's go and update the configuration for the web app. So in the folder DevOps deploy, there is going to be a file called all.yaml, and there should be one file for each environment. So the name of the YAML file should match the name of the environment. Now we want to create another environment called prod, and the value for this environment variable in production is going to be different. So we override that value. Now that we are done updating the configuration for this, we are going to push the changes. We are going to repeat the same process for our API project. We have updated the deployment configuration for all 3 microservice code projects. We are ready to update the Magic Pipeline reconfigured to deploy to the new environment. So clicking on update, push code changes to the Git repository. New code changes will include the changes necessary to deploy to production. So we see two new files have been added, and those two new files are for deploying to production. We are going to repeat this for the other two microservices. Pipelines have been updated for all three code projects to deploy to production. When GitHub builds the project and pushes the images to the artifact registry created by Planton Cloud, it is possible to verify that images are being published to the artifact store by going to the artifact store. You can click on view details and you can go to Docker images and see that API and website Docker images have been pushed to your artifact store Docker's repository. And the web apps build job is still in progress, and that is why we don't see the Docker image yet. Deployment to both dev and production have been successfully completed for the website. API and web app website is live in dev. API is live in dev. The web app is also live in dev. So we see that the API returns the same data that we are looking at on the UI. We see that the app is live in prod. And let's see if we see the API is running in prod. So notice that the API in production returns a different set of data because it is communicating with the database in production, whereas the API in dev communicates with database in dev environment. Let's add an action to see if the data gets added to the production database. So this is prod demo task, and click on submit, and we see that the data is persisted. And when we refresh the dev app, we see different data, and we see the task that we have created in dev, and for prod we see the production app. We have dev environment working and production environment working. We don't want our customers to use the endpoints that contain environment information and the branch information. It is possible to accomplish this by creating custom endpoints. You can go to endpoints, you can click on custom, and you create the desired endpoints. So we want to create PC Live to do to show the website, which is running in production. We want SSL. This is going to be for website. We click create. We want another endpoint that renders the app. For that, we want to create app pclivetodo.com, and the backend environment is going to be production. We want SSL, and we want to render web app for that route. As soon as we create those custom endpoints, the DNS will be automatically updated, and we should see new records. pclivetodo.com and app.pclivetodo.com have the IP addresses. The website is live on the endpoint that we would like to, and we are still waiting for the app. After a minute, the new endpoint is available. So we have successfully accomplished our goal of creating two different environments. Now let's make a small change to our app to change the title of the app and push the change to GitHub and see if the change gets automatically built and deployed to dev and production. So right now we see a Next.js to do app in Planton Cloud. We want to change it to live to do app. Save it. And now that there is a change, I'm going to push. As soon as the change is made, we should notice that a new pipeline will be triggered automatically by GitHub, which was added by Planton Cloud. The list of features that we have explored so far in order to create our dev and production environments are only a tip of the iceberg and contribute to 10% of features available on Planton Cloud. Let's quickly go see what other features are ready for the customers. To deploy the dev and production environments earlier, we have utilized Planton Cloud's hosting services, meaning the customer doesn't have to bring their own cloud accounts. However, Planton Cloud does have built-in support for bringing your own cloud account. Right now we support GCP, and AWS support is going to land soon. So you can bring your own cloud account, and then you can create what are called hosting environments, meaning all the Kubernetes cluster and other infrastructure gets created in your own cloud account, and your environments can also be in your own cloud account. Planton Cloud also supports hybrid model wherein you can create dev environment in Planton provided cloud account and keep your production environment in your own cloud account infrastructure, but you will not notice any difference whatsoever. Along with the resources that we have explored so far, you can also create Kafka clusters and storage buckets, and support for more workloads is going to land in the next couple quarters. For enterprise customers, there is built-in support for bringing your own identity connections, meaning all of your employees can be granted access to the console by integrating your own identity provider with Planton Cloud. All your associates don't have to go through a sign up process. They can access the console right from your own single sign on dashboard. IAM built into Planton Cloud feels and looks very much similar to what you see on Google Cloud. The reason for similarity is both of them are built using the same technology called Zenziber, which Google released a paper on. I hope that this video helped you understand how Planton Cloud can help you get off the ground quickly without work on your end to manage your operations. This will allow your developers to focus on writing code and shipping features, leaving the operations part to Planton Cloud. Thank you.